All right, hi guys. We are looking at the next part of our unit over logic. So last week we looked at inductive and deductive reasoning. So now we're going to use both of those kinds of reasoning to look for different parts of our next section, which is on what's called conditional statements. So specifically, what is a conditional statement? Well, statement, like you know in English, is just a sentence or something that's being stated, a topic or an idea that's being stated. Whether you make that conditional statement from inductive or deductive reasoning, it doesn't matter. But a conditional statement is a statement that has a condition or some kind of a prearranged rule added to it. So to look for a conditional statement, like it says there, it is an if-then statement that includes what we call a hypothesis. Whoops. Okay. So I'm going to zoom in here for a second, guys. Bear with me. All right. It includes a hypothesis, which is in geometry and our conditional statements, that is the if part of our sentence, and a conclusion. It's a little smudgy there. Let's fix that up. Which is a then part of our statement. So we have what we call a template here, which says if P, then Q. So we let our hypothesis be represented by the letter P. So it's a little short statement here. Our conclusion represented by a Q. So if our hypothesis statement, then our conclusion statement. And we have a symbol, a set of symbols that represent that, which is P with an arrow pointed to it. That is our symbol for a conditional statement. So let's see if we can identify the parts of our conditional statement here. All right, so we have the conditional statement. If two angles form a linear pair, then they are supplementary. So this is cut into two pieces here. One part is before the comma, the last part is after the comma. So everything before the comma, but after the word if, that is our hypothesis. So our hypothesis is two angles form a linear pair. That is our hypothesis. Whatever is after the word then, stopping at the period, they are supplementary. That is my conclusion. Okay, so again, hypothesis is after the word if, stopping at the comma. Conclusion, after the word then, stopping at the period. So that is our conclusion. Now, once we can identify the parts of our conditional statements, we can rewrite those in three different ways. So the first way we have is called the converse, which is formed by switching the hypothesis and the conclusion. So if you notice, the P and Q have switched. P and Q switched. Whatever was at the beginning, it moves to the end. Whatever was at the end, it moves to the beginning. So let's rewrite this. So that same sentence as before. So we start with our if, but instead of starting with two angles, we start with if they are supplementary. Comma. Then our hypothesis happens. Two angles form a linear pair. Period. So the two just switch places on us. Now, another form that we can write of that same conditional And we'll get to that in just a second. And again, notice even the symbol in the two letters have switched orders. So going from there, the next one that we have is called an inverse. An inverse is formed by negating. Formed by negating both of the hypothesis and the conclusion, which means take the opposite of. That's what negate means. Take the opposite. So if we had the sentence, it is raining outside, the opposite, it is not raining outside. Or if I told you I did not make the cake, to negate, I did make the cake. Okay, so we bring in either the word not or some variation off of that, or if it is already there, then we remove it. All right, but we need the opposite of that statement. The overall general idea of the statement is going to stay the way it is. I don't negate something by saying it is hot and then I say it is cold. That is not a negation. It is either hot or it is not hot. It is either not cold or it is cold. That's how we negate. So if I take my same sentence that we had before, the same hypothesis and conclusion, we rewrite it. But we just leave the order the way it was at the beginning, your original conditional. So if two angles form a linear pair, so in this case, if two angles do not, there's my negation word, form a linear pair, comma, then they are not supplementary. Okay, so again, there is our negation words. When we bring in the not, those mean you have negated that phrase. Now, our last one is called the contrapositive. And the contrapositive is formed by doing both. We have to take the negation and we switch them. So it's formed by switching and negating. Both of the conditional and both of the hypothesis and the conclusion. So let's try this one. So if whoops, sorry, let me switch this. If they are not supplementary, comma, then two angles do not form a linear pair. Okay, and those are our three forms. Now, let's talk about if we can prove these statements are true or false by finding counterexamples. So if we go back to what we call the truth value, it's all related to your original statement and whether or not you can prove that original conditional is true or false. So like it says down there at the bottom, this statement will have the exact same truth value as the contrapositive. So whatever we can prove for the contrapositive, whether true or false, the original conditional will have the exact same one. So if I come over and I look at my original statement, If two angles form a linear pair, then they are supplementary. That is a true statement. This one is true. Because by definition, linear pairs make a straight line. A straight line is equal to 180. So if two angles are forming a straight line, they are adding up to 180 and they are supplementary. So let's move on to the converse. The converse says if they are supplementary, then two angles form a linear pair. That is not always the case. I could have two angles that are not adjacent, not touching each other. They are supplementary, but by definition, linear pairs must be adjacent. So let's check out the inverse. If two angles do not form a linear pair, then they are not supplementary. Well, again, that's not the case. I could have two right angles, both being 90 degrees. One, they may not share a side. So then therefore they are not linear, but they are still supplementary. So this one is also a false statement. The contrapositive, if they are not supplementary, then two angles do not form a linear pair. So if two angles are not adding up to be 180 degrees, then there is no way they will form a line. And if there's no way they form a line, there is no way they can be a linear pair. So this one is true. So notice we've got some that have the exact same truth values. Again, for contrapositive, it has the exact same truth value as the conditional, while the converse and the inverse have to have the exact same truth values. So guys, I hope you liked learning a little bit about our conditional statements and the multiple parts and ways to rearrange them and rewrite them. Please don't hesitate to reach out to me if you have any questions, and I hope you all have a great day.